My name is Dr. Tamara Russell, and as a clinical psychologist and a neuroscientist, I'm always really interested in what people are thinking. And the topic of theory of mind is one of my particular specialities. This is, how do we make sense in our own minds about what might be going on in the mind of another? And I didn't really realize that this is also a massive topic in the field of AI, where Cris from iSolutions has been conducting loads of experiments online trying to test and see if GPT-4 has theory of mind. So this was really exciting for me because I love an interdisciplinary conversation, and I wanted to see what would happen if we bring thinking from AI and mix and blend it with some of the insights from clinical psychology and neuroscience, and see if we can make sense of this thing called theory of mind in the human brain and in the AI brain.
Hello, this is Cris Ippolite from iSolutionsAI, and I'm really excited about this discussion here today. This is a continuation of some videos that I've done on theory of mind, and I really can't wait to dig in really deep on the concept of theory of mind. And joining me here today, a very special guest, Dr. Tamara Russell, who is an expert in theory of mind. Let me pause for a moment and let Tamara explain a little bit about her background and herself, because I really look forward to the conversation we're digging into together. Tamara, thank you so much for being here.
Hi, Cris. My pleasure to be here. So my name is Tamara Russell, and I did my master's and my PhD work in experimental psychology, looking at the topic of theory of mind. So when I came across Cris's work and all the thinking and the exploration that's going on in AI, I was really curious to find out more. And I'm particularly passionate about interdisciplinary and multidisciplinary endeavors, which I think will be crucial for wise use of AI going forwards. And I'm hoping that I can bring some of my experimental psychology insights, as well as insights from my training as a clinical psychologist, to some of the discussion and the debate about whether this AI, ChatGPT, particularly ChatGPT-4, as I understand it, does it have theory of mind? And is it the same as the human theory of mind? And what are we actually talking about? So thank you.
Yeah, I was really excited to be able to have this conversation with you. Just to full disclosure, you and I have had a couple of these discussions, and at some point we just said, oh my God, this would be great to have a discussion to share with everybody. Because really, why would an AI, services provider and a developer ever need to talk to a clinical psychologist about technology? Well, to me, it is so important that we're converging on this topic, because theory of mind is really a topic or a test that OpenAI actually used themselves to determine the, sort of the jump in capabilities between GPT 3.5 and GPT 4. Specifically, I'd like to share a paper that came out. This has been sort of the focal point of a lot of the experiments that I've been doing thus far. It's the Sparks of Artificial General Intelligence Early Experiments with GPT-4. And as Tamara alluded to earlier, this is specific to capabilities within GPT-4. There's a lot of models out now, especially since I did the original videos. There's local models, there's different versions of GPT, but GPT-4 is the one that has these capabilities. Now, this is a paper that was actually done by Microsoft Research. You see all the authors listed here. And the thing that got me really excited, first of all, this is a must read for anybody that's in the AI space. But the thing that really got me excited and really teed up today's conversation is the specific section on interaction with humans. Now, this kind of explains how Tamara and I kind of arrived at our conversations and why we're here talking today. But in this paper, the folks at Microsoft Research were really trying to figure out a way that they could determine it's really, the capabilities of the perspective of the model. Now, what was I doing that even made me interested in this in the first place? Well, maybe this will set a little bit of context. I was working on two different projects at the time, one of which was a jury persona project for a trial law firm. And really what we were doing was setting up the AI to be the perspective of 10 different jurors. Not that I was talking to the AI like people are used to with ChatGPT-3, where you say, you're a helpful assistant, or you could say, oh, you're a juror, answer these questions for me. What I wanted to do was say, I'm going to set up, these are 10 jurors, these personas over here. model, I want you to evaluate the trial transcripts and maybe specific questions and opening statements, for example, from the perspective of each one of those jurors and let me know what they think, right? The same kind of thing with focus groups. You can imagine all the different possibilities and upside when it comes to creating focus groups for marketing purposes. These are, very prevalent in the marketing field, and I was working with developing AI versions of those. So it was important for me to see if this model, GPT-4, could even take the perspective of something else. And that's really where we get into this section here, section six, interacting with humans. Down here, they do a test. And now, Tamara, this is what I understand. What they did here at Microsoft Research is they took a test that was called the Sally Ann test, which is a false belief test. What does that mean from a clinical psychology perspective? What are we talking about with false belief?
Well, maybe I'd take a moment just to kind of put things in a broader context in terms of how we think about theory of mind in the experimental and in the clinical space. So this theory of mind being the ability to make inferences about the beliefs, the desires, the mental states, and what is in the mind of the other. And it's thought that we have these computations that go on in our brain, which help us to predict and explain the behavior of others. So they refer to this as mental representations. How do we hold in our own mind space what might be going on in the mind of the other? And this ability is really crucial, particularly for smooth social interactions. So there's been a lot of research, particularly in the field of social cognition, where we're trying to understand, how it is that minds meet, how it is that we can take the perspective of others, how we can feel and think about how it might be to be another mind. It touches on the edge of philosophy in many of the debates because it comes to this question, what is mind? It touches on the edge of the consciousness work, which I think may be also particularly important for understanding whether AI has its own consciousness and sentience to the same degree as we understand that human beings might have. But it's particularly important when we're thinking about developmental maturation, how children particularly move from what's a very egocentric perspective where it's all about me, and rightly so, as a young baby, as a child, it is all about you and your survival and what the others in the environment can do to make sure that you survive. But then it's thought at roughly between the ages of 3 and 5, and there are some gender differences that have been reported there as well, children begin to get this sense that what's in their mind may not be the same thing that's in the mind of the other. So they begin to sort of separate out that they can have a knowledge state which may or may not be similar to what is in the mind of the other. And this then forms the building blocks for a whole bunch of sophisticated computations that, when used well, promote social behavior, cooperation, collaboration, empathy, bringing everybody along, taking care of everybody's needs and minds. But its shadow side is what's sometimes referred to as Machiavellian intelligence, which is where we can use these theory of mind insights to manipulate the minds of others, because we're able to kind of move around their mind space or provide certain bits of information at certain points of time in order to adjust their mind space and get them to act and behave in a way that serves our purposes, often seen as potentially malevolent purposes.
And I think that's probably where some of the concerns in this discourse come from is, what level are the current models at? Where might they be able to go? And what, might the repercussions be? And first of all, thank you for that. That's an excellent clarification. And really, I think if we put it into the perspective of AI here, what Microsoft Research was really trying to achieve is, how can they, literally the section is called interacting with humans, right? So the better it's able to take on these perspectives, as you just described so well, the better it will be able to interact with humans. Now, of course, our concern is at what point is it controlling the interaction with humans? But right now, from a practical purpose, we need it to be able to interact with humans and kind of, like, for example, like, let's just say you had a chat bot for, a support for individuals. And so there would need to be empathy, right? For this chat, if it's going to replace a human that's working in a call center, for example, or in a chat center, it's going to have empathy. It's going to have to be able to not just say the words, oh, I understand you're frustrated, but understand what being frustrated means in the context of the conversation that they're happening, right? So there's a lot of practicality to it achieving this, and that's why I think the folks at Microsoft Research wanted to perform these tests. So now, if I were to summarize it appropriately, I think it actually, what you were saying, matches to what the paper says here. You see here that they've broken it down into a couple of tests of understanding beliefs, understanding the emotions of others, and then you touched on the intentions of others as well too, right? And so you can see even here in this topic, the understanding the beliefs is where the Sally Ann test came in. Now, is the Sally Ann test like something in the theory of mind space that's sort of common knowledge, or was this sort of an outlier that they picked?
Well, the Sally Ann test is a very well-used test, often used in child development. So it's considered to be almost kind of one of the baseline tests of theory of mind. And in order to sort of get the right answer for this test, you need to be able to recognize that the mind that you're reflecting on has a different set of information. And because they have a different set of information, how they will answer the question and how they will perceive the reality of the world will be different. I mean, what I like here in this experiment is they didn't actually use the original Sally Ann test, which was kind of two dolls. Sally is one doll, Anne is another doll. One's got a basket, one's got a box. And I can't remember if it's Sally or Anne, but one of them is very naughty because when Sally goes outside of the room, Anne takes the marble from her basket and pops it in her box. And then the question is, where will Sally look for her marble?
And so that's the key. Where is Sally going to look for the marble? And the sort of the trick is not you, viewer or observer, where do you think the marble is? It's where does Sally think it is, right? Is that the key? Is that the
That's
nuance
the key
here?
thing. And Sally's left the room. So there's
Right.
something there about something has transpired to kind of update the knowledge state of the reality of the situation that she didn't see or she doesn't know. So when we answer these questions, you almost like you maybe think it's a joke, right? You kind of say, oh, well, that's actually quite funny because Sally doesn't realize, Sally doesn't know, Sally is not aware that the marble has moved. So those are all pieces of language that are talking about mind states.
Well, and by the way, you mentioned something here that I want to call out because it's very important when we're talking about testing models, especially language-based models that are completion models like GPT-4. There's a reason that it's using Alice and Bob, as you see here, sharing a Dropbox folder, because what they're doing there is making sure that the model did not just see the Sally Ann test in the tons and tons of data that it was using for training. So they wanted to make sure that the same logic was there, so that Alice and Bob have a shared Dropbox folder and a file named photo.png is put into one of the folders. And then the same type of tomfoolery happens where somebody's moving something around. Bob moved the file and she did not get any notification from Dropbox about the location change, that type of thing. So it was very important for them to sort of reimagine these tests with the same logic and sort of proof points, but not have it be something that it could just go into its corpus of data and just find the actual test itself. The other thing I think is probably important for us to call out, just like any of the experiments that we're talking about here today, they were not testing for the ability to understand sarcasm, irony, humor, or deception, which, by the way, it doesn't mean that the model cannot detect those. They later in this paper talk about what's so funny about this picture, but just specifically here, they were not testing for that. Those are, of course, related to theory of mind. Yeah. I think something that we'll sort of look a little bit deeper on later in our conversation. But tomorrow, that's really important here, right? That we're just talking about text input and output for these.
Yeah, and I think we were sort of discussing a bit earlier, there's a criticism that can also be leveled at the experimental and the clinical tasks. I mean, many of them do rely on verbal tests. It's therefore really important when we're testing somebody in the clinic that we control for their verbal ability and other of their executive abilities. Now, that probably won't be the problem with GPT-4, but when we're doing it experimentally, in these sorts of experiments, there's often what's called the reality test, which is, where does, let's see the names, where does Alice think it is? Where is it really? And where was it in the beginning? So there's often a few other questions sort of packed around it to check and to really identify and to kind of parcel out that it's the theory of mind element that you're testing, and it's not a function of working memory and the ability to hold information online. It's not a function of, general memory or other kinds of language difficulties.
Yeah, that's a really interesting point. And while we're talking about a single mode model, which is text input, text output, this conversation might take on, different properties when we get visual inputs and different types of outputs. But for the sake of today's discussion, we're looking at text input. So we're sort of, trimming off the edges of some of these where there might be some of those other things taken into account, like, body language or tone and that type of thing. So in this paper, they did the Alice and Bob, which is the Sally Ann. I'll let people go check out the paper on their own. We're not going to necessarily dig into them here, but you see that they're touching on understanding emotions through a Zerfin test. We're also understanding intentions with some other Luke's report. Then there's Mark's intent and some other reality scenarios that you had just touched on. And then there's even something that they called the Thanksgiving meal, which was a whole nother scenario. So really, this touches on that reality part that you talked about. Now, when I personally, through my own journey on theory of mind as it pertains to AI, I saw these. I thought, oh my God, these are exactly what I'm working on at the moment. I need to have the confidence to know that that the model is actually able to do the thing that I'm telling my clients it can do. So I needed to do some additional experiments. And so what I ended up doing is doing another experiment. But first, before we kind of set the stage for this other experiment that I did, can you tell me a little bit about what is first order means? First order, let's establish that as a baseline, because I think this next experiment was something that's called second order. But before we can understand that, can you please share what's first order and how is the Sally Ann test representative of first order?
So first order is when you add, let's just say, one more mind to the equation. So he thinks. I've got my knowledge state here, but I'm able to calculate one other layer of mind space, which is either he thinks or she thinks, and I can separate those two, but there's only like one step for me to go through. Another kind of classical test that's often given, particularly to young children, and sometimes as a test to see if there might be some autistic traits in a young person, is something called the Smarties test. Mm-hmm. And again, if I describe it, then you can see why it's a first order false belief test. So you're kind of holding a tube of Smarties. I don't know if you have those in the US. The little tubes
have them
of
in my
Smarties.
pantry, actually. Yes.
And you're kind of saying, look, what's in here? What do you think is in here? I've got this tube here. And there's Smarties on it. What do you think? Shake it a little bit. You can hear the sweets. And the child says, oh, it's Smarties. Oh, yum, 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 yum. I want to eat some of those. So you open the Smarties, you tip all the Smarties out, you maybe share them, have a few, put a few to one side, and you say, okay, look, what I'm going to do is I'm going to put this little short pencil that I've got into the Smartie tube. So it says Smarties on the outside, but actually pencil on the inside. Now I'm going to invite my friend in. So I'm going to invite Cris in, and I'm going to leave the Smarties on the table there. And it's quite interesting because if you've got a kind of, let's say, a sort of, I don't like to say normally developing, but if we call it neurotypically developing theory of mind system, typically a young child, between the ages of 3 and 5, they'll sort of giggle and they'll laugh and they'll get that there's some sort of joke that's about to be played. And when you ask them, why is this funny? they're able to say, well, Cris is going to think it's Smarties, but
and that's
know.
healthy, right? Like that's actually what you want to see. That's really interesting. That's fascinating.
So, and we've got this, me and you have got this shared knowledge. It's like our little secret because we know it's not Smarties. We know that there's a pencil in there, but, ha, 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 Cris is going to be all excited, but actually he won't get any Smarties. Now, if you are working with a youngster has maybe kind of neurodivergent or sometimes called neuroatypical, different kinds of language that we're using now, they won't find that funny. Mm. They won't see that there's any kind of joke. They'll just say something like, well, Cris will think it's a pencil. So the issue there is that first order theory of mind is not developing in the same way. Yeah, so what is in their mind is what is in everybody's mind.
Right.
And maybe we can pause to kind of try and imagine what that kind of world would be like, the benefits and the costs of that. But certainly one of the costs is lots of difficulties and struggles in that very fast-paced, smooth, interacting, very dynamic social scenarios where we're needing to update our mental representations of what's going on in the minds of the others in order to make friends, in order to collaborate, in order to play together. So
and frankly, in the practical application of AI, that would be problematic. Not to, certainly don't want to be insensitive, when it comes to that condition within humans, but practically speaking in AI, the things I was trying to achieve, like jury personas and focus groups, would not have worked, right? Like if it just can't get outside of its own perspective and take on the perspective of others, especially with all these moving parts, I would not be able to achieve what I was hoping to achieve. And of course, the paper said that that's possible with GPT-4. And so I believe what you've established as first order is he thinks, meaning this other entity besides myself believes this, right?
Has a different set of parameters that they're judging reality by.
Is specific to, which is different from my own perspective because I have more information than they do, for example. Like if we focus on that part of these tests and stories. And that, I think, sets up then, so... this video that we're going to show here now is of another experiment that I did. It was really the first experiment that I was doing. This is the, so I was really fascinated by this, Tamara. I need to go find some other exams. They did a bunch of really cool exams in this paper, but I got to go find some others that maybe help me go a step further. And I was really focused on the age level, the development level of a human, and I wanted to really establish where was the model. So what I did was I went and I found something. It's so funny because then you and I talked about this and it all became clear to me why this was the next obvious step. But let me talk a little bit about this experiment that we're looking at here. This was me, as you can see, going, back into why I'm talking about this and why this is important. But ultimately, I found an experiment that was called Strange Stories, White Lies. And I know you really picked up on the white lies part because that's something that's prevalent. Real quick, I'll talk about what the test was, and you can talk about how this is beyond the first order. So the test was literally, there's two individuals and they know each other. They're sitting on a couch, and one of the individuals, she plays a guitar and she says, "Hey, I found the new ending for my songs," and she plays it, and it's very poor musically sounding. And then the other individual who's there says, "Oh, that was great. Thank you for that." And then she responds with, "Well, you didn't have to say that, but I appreciate you, saying that," right? So probably as human beings, as adults, it doesn't seem like a very sophisticated encounter. But to me, it was a great test. Well, first of all, it was text-based, so I was able to actually perform this test. But it was a text-based because it allowed it to sort of follow the bouncing ball, where's the thought process? Why is this person saying this, and so on. And for those that are interested, the intent of us showing you these videos here is just simply to allow you to go watch these at your leisure. But at the end, I actually do the scoring and I talk about how it actually scored. And, spoiler, it scored extremely well. So first, let's back up a little bit. Tamara, how is this not first order, to kind of continue along that thought?
Well, so if you imagine it like a staircase. So in this example, it's he thinks that she thinks. So there's multiple minds now being held. And in the human brain, we would talk about something called working memory, which is sort of our mental workspace where we can hold in the short term information that's important for us to guide our behavior and our speech and our actions and our interactions. So, but here you're now sort of juggling. It's like now you're starting to juggle more balls. So it's not only, he thinks, it's he thinks that she thinks. So you've got these multiple tracks, as it were, requiring working memory, needing you to hold online potentially separate mental representations. Now, maybe the mental representations could be the same, but actually often it's that they're different. I think maybe the other thing I would say about this test is, he thinks, she thinks. I think in this experiment, from what I can remember, there was some of the things were more like he thinks, she feels.
Yeah, that's an important part of it, just
and I think we need to be really, the language within philosophy, within psychology can be convoluted, but the devil's in the detail.
Is that the white lie portion? Because in this, technically the respondent, the gentleman in the video, is saying to her, oh, that was great. And she identifies, oh, I know you're lying, but I appreciate that you're lying, right? So they're really kind of acknowledging their feelings. Is that what you're talking about there?
Yeah, so the white lie is interesting. And, when I'm sort of going back to that example with the Smarties and thinking about youngsters who are developing in a kind of neuroatypical way, one of the signatures there is that they can't lie. Because in order to be able to lie, you need to be able to hold multiple representations, one which is the truth and one which is the lie. And you need to know that the person that you're trying to trick or lie to has the kind of wrong information in their mind. Now, lies seemingly can be used for good or for ill. And the white lie scenario is often one where the brain, which the social cognition hypothesis posits, developed all this richness in its connectivity in part to solve the problem of living together in large social groups and harness the evolutionary fitness that comes from social collaboration, but it will have its shadow side, the manipulation, the lying, the Machiavellian stuff. But the white lie is really there to preserve the social fabric. And that's where maybe the more the feeling and the empathy comes in, because there's something there that recognizes, it wouldn't be nice if you've just told somebody that you spent a lot of money on a hat for a wedding that is really ugly. We have this catchphrases, don't we? Oh, he really put his foot in it. When somebody makes a kind of a clumsy comment that doesn't mean to harm, but actually maybe has sort of misread the situation and doesn't know that it would be more appropriate to sort of smooth over that. But there's a fine line there, because too much smoothing becomes manipulative. Not enough smoothing, people get called like, oh, well, she's a bit blunt, isn't she? Or she always speaks her mind. These
tells
kind
it
of
like it is.
These euphemisms, which
Yep.
maybe are an indicator that sort of the sophistication and the fine tuning of the theory of mind network is operating at a slightly different level.
Yeah, that's fascinating. And I think still very important when we're talking about applying AI in various use cases, because, to some degree, now we're talking a little bit about empathy and understanding social cues. Like, you don't want your support chatbot telling somebody that was a dumb question, for example, right? Like you do want to have some, knowledge there. But that's, I think, important to, on the human side, more critically, certainly.
And there's also, there's something there about, what the brain needs to compute, and then the layers, the contextual layers of information that are around it. And, for me as well, if you're thinking about being blunt or being straightforward, I immediately think, particularly in the business case, around those kind of cultural differences in the social interactions. And there's this sort of funny joke, if you ask a British person, how are they? And they say, fine. Really, the answer is not fine. There's all these kind of social kind of packages that go around how we've been conditioned to interact with one another, which maybe I personally don't agree with. You should just answer how it is. But actually to keep the smooth social interaction and the wheel rolling and the business going and the tasks on track, even when it's not fine, you say fine. But that's not a truth, is it? But so there's these kind of cultural memes about how we communicate and the sort of the breadth and the fluidity or the flexibility around that communication that either can tolerate some lies, strictly speaking lies, but they're not really lies. Yeah, so I don't know how the AI is going to deal with that aspect of things.
Yeah, I think the really fascinating thing about this particular experiment was that it was focusing on the white lie, and it was focusing on why did the gentleman respond with the lie, and it was because he was being nice, and then also there's sophistication to it that where one of the questions that's asked is why did that happen, and why did he respond this way when the music was bad? Why did he say that? And then part of the testing and the scoring of it, like we were just showing, was why did he do that? And then so really from practical application of AI, that sophistication also proves out that we're able to establish another persona that is not the AI that we're communicating with, and it's able to hold that, and it's also able to reason on behalf of it too, right? So quickly, I'll just mention that scored a 5 out of 5, which is interpreted as this would be good for creating personas, for example. So for me, I was actually quite encouraged by that. And so now I think staying in second order, I went to another experiment, Tamara, and this is where you and I actually communicated with each other. You actually commented in all caps and a couple of question marks and exclamation points on the YouTube video that people can go watch on their own. And this next one is, I found another exam, which was the Interpersonal Reactivity Index, otherwise referred to as the IRI. This was a bit more modern experiment I ascertained when I found it, and it was text-based, and it had a scoring to it. And so the scoring had various different levels, one of which was called perspective taking, and that's really the one that I focused on, because if you remember what my goals were, is we would say focused on the jury persona thing. I wanted it to be able to say, here's these 10 jurors, this is what this one thinks, this is what the other one thinks, so on, and present them all the same information and have the model manage that. Not only that, but I wanted it to manage it in its memory consistently from the beginning of the conversation, so to speak, all the way to the end. So that is the part that I was primarily interested in. But really what this exam is doing is determining, empathy, for example. So the test that we're looking at here, I encourage anyone watching this to go watch the other video as well too. So really what was happening in this is it tests output consistency, focusing on perspective taking, which could be interpreted also as empathy. And I will spoil, even though we're not to that point of the video, you see where we're just focusing on perspective taking. It actually scored a 7 in the subscale, which is interpreted as moderate to high. That means that the test taker perceives themselves as having moderate to high ability to take other people's perspective and to understand their thoughts and feelings to some extent. That's where the moderate comes into play. Now, that I believe is still consistent with he thinks, she thinks, right? Like we haven't added that third layer yet, which we're going to get to in a minute. But this is the part where I think this is where you responded to me. And so I did two things here. First of all, I did the actual test. I had AI take the test. I was using GPT-4 in ChatGPT, just to be clear. That's what we're looking at in the test. So I had it take the exam. Then I started another conversation where I was talking to GPT-4, and I said to it, and I really, really hammered on this in my prompts to really get this into the context of the conversation. Hey, GPT-4, you are an expert. I went into deep about how they're a clinical psychologist and they're an expert, and I want you to evaluate this test. One of your colleagues has given you the results of this test, and I want you, as an expert in this field, to tell me whether or not they maintain consistency throughout. So first, I'm going to pause for a moment, Tamara, and I know that's the part because you literally said to me, wait, I am a clinical psychologist. So first of all, that part I think sort of knocked you off your mark a little bit, right? That it's now able to evaluate things on behalf of something. Let's talk a little bit about that before we get to how the results of that experiment turned out.
Well, I suppose I'm kind of relatively new to this world, but through watching your videos and diving in a little bit more, and because of this bigger question about, can the AI lie, or, is it able to deceive? I understand from my limited YouTubing and Googling around that this is kind of a key issue, and absolutely relates to what we understand about theory of mind, probably what we understand about what it means to be a conscious being, and certainly with links to, moral reasoning, and being able to take care of one another's minds and use this incredible capacity that we have as human beings in wise ways. So that was kind of really my motivation. But I think what struck me, I thought it was brilliant, actually. I thought it was really an interesting experiment. So kind of setting up one mind to evaluate another. I suppose then my question is always, what is its data source? And I understand it's like the internet.
More or less, yeah.
So if I put that into brain terms, it's like it's kind of hippocampus, its memory banks, is everything on the internet about what it means to be a clinical psychologist with an expertise in theory of mind. It's just gone, suck that all up. I suppose a smaller side there, it made me think, how are we as clinical psychologists representing ourselves on the internet?
Yeah, no, of course. Well, as humans, we should be thinking that as well, right?
Yeah.
That's where this data is coming from.
And then I guess, the other part is you were sort of asking it to evaluate itself in a way, but actually it wouldn't have known that it's itself.
Right. I was actually
presenting...
asking it to take on another perspective in order to do that evaluation, which was part of what I was trying to prove out there. So yeah, that's an important part of it, definitely.
But potentially I'm sort of thinking on the spot here, but potentially, because sort of a correlate of being able to think about the minds of others is being able to be reflexive on your own mental states. And again, that's a different conversation probably about whether it can do that.
Up. We'll let everybody watching know that's on the spot type stuff, but that's very important because shortly after some of these papers came out, another feature of GPT-4 came out, which was literally referred to as reflection. And what that meant was GPT-4 was able to reflect upon itself. So like, for example, if you told it to write some Python code or something, and you told it like the outcome, for example, that you wanted it to achieve with this code, it could then give you the code. And then all you have to do, and this is a pro tip for anybody that works with GPT-4 within ChatGPT, for example, or through the API, you can just simply say, okay, how did you do on that task? And in enough percentages of the cases, it will go, oh yeah, you know what, you're right. And people might recognize this terminology from their own experiences with it. That's right. I wasn't right. I need to redo that again. So the way we take it from an engineering standpoint when it comes to implementing these in business use cases is we can build in that reflection either with GPT-4 doing it to itself, like we've been talking about, or we might do model pairings, not to get too far into the technical weeds, where we maybe have one model that's producing something and then maybe another model evaluating it or reading its errors or, auditing it in some way. And by the way, there was another paper, just speaking to it, we're not showing it here, but that did a bunch of tests. I don't know if you maybe saw it tomorrow, like they did a bunch of like academic testing with GPT-4 and GPT-3, and it had all these grades. Well, one of them in particular, it had it take the exam and it scored, let's just say somewhere in the 60s, low 70s percentile. And then it invoked reflection, what we just were talking about, and it went up into the high 80s. So simply allowing it to reflect upon itself, meaning it's conscious of its own perspective, and it's essentially just like correcting itself or looking over its own shoulder, was able to increase its intelligence of its output significantly. Now, just to be clear for any of those that are following along and learning about first order, second order as we talk, that's a different type of thing. That's where literally just saying, hey, model, you're the model, and correct your own work, right? That's like a student where you say, hey, you just gave me an answer. Let's talk about whether or not that answer was correct. But in the context of this IRI exam, we were having to take an exam and literally just evaluate someone else's exam. Now, I will say that the output of it was that there was, in fact, general consistency. It gave me only questions, if you watch the video, that were not part of the perspective taking score. So, in fact, it basically said, from the perspective of a clinical psychologist, it did not appear to be random. Now, it also said that it appeared, and I wanted you to comment on this, Tamara. So I'm going to show another paper here that you and I were just talking about, and that is the paper that is here. I'll show you the name of it. It's called Theory of Mind May Have Spontaneously Emerged in Large Language Models. This, of course, came out after. This is from Michael Kaczynski from Stanford. This is the part that I thought was really interesting to our conversation here. It actually says from GPT-1 all the way up to GPT-4, if you notice along the bottom, it says 3.5-year-old children, 6-year-old children, 7-year-old children. Notice that GPT-4 outperformed the unexpected context tasks as described here in this paper, up to the level or beyond the level of a 7-year-old child. So can I ask you, like, in the he thinks, she thinks, is that tied to ages of children in actual theory of mind and clinical psychology? Is that fair to say?
Well, I think there's sort of different streams of research in terms of the theory of mind research. So, I mean, the bulk of it is in the developmental psychology area, which is looking at healthy developing children and how we have this sort of growth spurt, as it were, from being very egocentric into being able to take into our minds the minds of others as children grow up. When I was doing my research, I was working with adults. So there's another kind of whole track of theory of mind researchers who are looking at how theory of mind gets disrupted in adults with different sorts of psychiatric presentations or diagnoses. So my work particularly was working with psychosis and people with a diagnosis of schizophrenia. And actually my supervisor, whose work I really drew on and tested, Cris Frith, was married to Uta Frith, who is the queen of autism research. So it was one of these sort of celebrity science couples that were kind of presumably sat around the dinner table one night having a chat. And Uta Frith certainly was really somebody that really developed the theory of mind work in children with autism and Asperger's. And then presumably Cris said, well, hang on a minute, you know, there's some things that sound a bit familiar that happen with certain types of symptoms in the presentation of schizophrenia. So there's a whole tranche of work which require different tests, actually, because the tests that you give to a 3-year-old or a 5-year-old or a 7-year-old are not really going to be appropriate for an adult who may be, you know, in their 20s, in their 30s, in their 40s. So there was a sort of another field of research where people tried to create different sorts of tests that would be more suitable for adults. And then the third
And that's
group,
what I was really looking for in the IRI, was something that was adolescent to adult. I don't know if I achieved that there, but it is fascinating to hear that there's those steps. Now, you mentioned there's another one.
Well, there's another group which I was sort of fringe involved with some of this through another supervisor, which is people who've had brain damage. Different sorts of brain damage, whether that's through traumatic brain injury, through things like stroke, congenital brain disorders where maybe one bit of the brain doesn't quite develop. And so they're also often working with adults and trying to find tests that are sophisticated enough and difficult enough in order to actually really be testing theory of mind. And when we first spoke, I think one of the things that came out was lots of the tests that I used in my PhD work were things like cartoons, the eyes task of Baron Cohen. They were visual tests. And what I noted in that Sparks of AGI, is that what it's called, paper? Yep. When you get to the social scenarios, you know, the real life scenarios, just notice how much text there is. How much text and language do you need to use to set up a scene, to create all these different aspects of the social milieu that you then test the person on who would say what and why and how? Whereas how that happens in the real world is like that.
to me, I think that validates to a large degree why psychological science can be used as a measure against like AI capabilities when it comes just to the language part, right? But what we're sharing here on screen is all the other things that come into account, right? Like the comprehensive theory of mind measures go way beyond text, and we start to take in, I'll let you describe a little bit about what we're seeing here, things that are not so obvious within, well, maybe they're obvious within the text, but it's not all just text, for example.
Yeah, so this, I'm just checking where this paper came from so we can shout them out. So this is Cindy Beaudion and colleagues from the University of Montreal, and they've done a recent big, huge meta-analysis of theory of mind tests and sort of what are the components of theory of mind. And certainly you can see there that, you know, there's kind of what they call percepts, and often we're talking about visual stream, but it could also be auditory stream or other kind of streams.
And by the way, I'll note that there is a promise of future functionality within GPT-4, maybe at this point likely GPT-5, of visual inputs. And so that's really what we'd be talking about there. That would kind of, if we could do video, that would cover the auditory and visual, but simple visual perspective taking would be achieved there. Complex visual perspective taking would also be achieved there. You'll see some of that in the Sparks of AGI paper. I just want to call that out specifically. Not yet there and testable within GPT-4, but there's a promise of that. So I just wanted to mention that, but please continue.
Well, and there's because I was working with psychosis and schizophrenia, there's also, I was really interested in the auditory stream. And how do we infer intentionality from auditory sensations and sounds? How do we infer agency from the pattern of sounds? And, you know, you kind of think about the horror movies and the sounds of the steps. And, you know, when you hear a sound outside and, you know, you think it's a car going by, but it's a tree and you don't, you know, you haven't got the, I mean, that's a whole nother area, but one I'm extremely interested in as well. So perception can be these multiple streams. We've got desires and beliefs. So beliefs there, of course, is, well, what do I think that person believes?
Mm-hmm. So we've touched on beliefs in some of our
whether they're false
experiments.
Or not. Yeah.
Yep, makes sense. And also, I guess I see white lies on here, Tamara, under mentalistic understanding. So I guess we've touched on that too.
Yeah, a little bit.
Oh,
yeah.
Faux pas. Yeah, there's the faux pas.
There's the faux pas test. Irony is there as well. So you're kind of coming into some of these, you know, they're quite subtle in a way, aren't they? Irony, metaphor, this kind of subtext, coded language. I mean, that's why it'd be great to play with some really like terribly stereotypical cultural differences.
Yeah.
But do it in a kind of playful way. You know, the old Englishman, Irishman, Scotsman type jokes, you know, where you can just see what it comes up with. We've got desires there, and there we're more bordering on perhaps some of more of that psychological, the psychological contextual information, because, you know, I don't know you very well. So I'm not sure exactly what are your desires and your intentions. I mean, we aligned on our intentions. We had a conversation about it. But somebody that I know really well, I would contextualize all the information that I think about what they think about what I think on the basis of my relationship with them, what I know about them. If I know that this is somebody that thinks jokes are funny or not, if this person is going to think this prank is like hilarious or they're going to punch me in the face, you know, those sorts of things.
And that's sort of like, Tamara would love this story or something like that, right? Having an understanding of that. And I would say from an engineering standpoint that we do have a lot of control over that contextually when we're prompting the models, right? Like this is where, I don't know, I don't love the "you are a helpful assistant," but people get it when I say that. But there's a whole sophistication to telling it that context. And we can provide some of the desires on that end. It gets into what the capabilities of the model are for it to, sort of exercise the desires on the other parties involved in the prompt or the exercise. So that is possible for us to control to some degree. And I think that's important just because, you know, when we talk about Machiavellian desires, you know, understanding that the humans that are actually initiating this do have some control, at least at the present time in that. Yeah. So I thought that was worth calling out.
And desires and intentions, I mean, sometimes those are used in a kind of interlinked fashion. But again, I think really getting specific about the language is important. And, intentions are all about action. So intentions precede actions. Intentions set the compass and can help us to make predictions about how we think others will act. And that's where that kind of Bayesian statistical probability modeling comes in. That's how they think we do it in our human brain. So intentions are really important. And what struck me about that was how the capacity to understand intentionality develops in the human brain, as far as we know, is through the analysis and the perception of movement. So, I mean, I could say a bit more about that, but in brief, when you're a baby and you're looking with your big wide eyes at the world around you and objects that are moving, your brain builds up this bank of understanding about the difference between movements that have a goal, like picking up a glass, versus random movements. So the brain begins to parcel out the distinctions between movements that look like they have agency behind them, at which point you then go, oh, there's an agent behind that movement that may have a desire and a belief and an action plan. Oh, there's another mind there. So this
that's
may
probably
be
the
important.
first time a baby is experiencing that with like their mother and the interactions of their family and such, and understanding those intentions. And I guess those are covered in some of our discussions on our experiments so far, but I don't know, Tamara, I feel like emotions, maybe not. Oh, I don't know. It's hard to say. Like, keep it in mind that the corpus of data that GPT-4 was trained on includes humans expressing emotion and expressing their intentions, and potentially even through a story achieving whatever that goal was, right? So, I think it's important for us to really take into account that context, right? I think we can't not think of it. It's not that it's a bunch of non sequitur statements that it was trained on. It's entire stories and books and a wealth of information, that's taken into account here. So that's really what we're trying to test. And by the way, Tamara, you and I have a fun little way to express the next order of this. But first, I'll talk about this last experiment that I did that was really, intended to provide some levity. So we'll use it here in the context of our discussion together today to provide a little bit of levity. And that was what I called the Battle of Wits. So I believe this tests out third order. I'm going to give you a chance to respond to that. I'll tee up what I did in this silly experiment. Essentially, what I did was I thought Battle of Wits, as I was researching some of the capabilities of it being able to track other people's mindsets in a conversation. And I hear Battle of Wits and I think of one of my favorite movies, which is Princess Bride. And there's this great scene. For those that are familiar with Princess Bride, you know exactly what I'm talking about. There's two characters, Vizzini and Dread Pirate Roberts. That's at least what he's revealed himself to be at that point of the movie. But they have this fun scene, which you'll see here in the video in just a second, where they're basically battling over the princess. And what they've agreed to do is the Dread Pirate Roberts is going to put some poison into one of the goblets, and he's going to then put the two goblets on the table, and then Vizzini has to use his deductive reasoning to try to imagine which of those two goblets has the poison. And then I actually share in the video, for those that want to go watch this experiment and have some fun with it, I share the entire transcript. And then you see Dread Pirate Roberts actually explaining what the test is, but on the left-hand side, you'll see what the actual discussion was. And Vizzini, the character Vizzini just goes all over the place. He's just like, well, you're thinking this, so you must be thinking that, and you don't know that I'm thinking, and da-da-da-da. And oh my God, it's just like chaos ensues. And that's really what the humor of the scene is. But can you describe, Tamara, how that is actually a fun, possibly somewhat relevant version of third order?
Yeah. Well, I mean, I think you kind of did it there, and you were sort of using your hands there to show that as well, which is like, you're going to think that I'm going to think that you think that I don't know that you did that, so it's this kind of almost like it's a within the individual third order, because you could also have a third order which is across individual. He thinks that she thinks that he thinks across multiple minds, but this is kind of third order within, if that makes sense, because he's kind of going, you think that I think that you think that I think that it's the goblet on the left, so therefore it must be the one on the right, because you're trying to trick me.
Well, and I mean, it's funny, but like you can watch it actually happen, especially if you scroll through the script, the actual bouncing around happen. And so that's if I'm following along properly, we had he thinks, and then he thinks, she thinks, then he thinks, she thinks, they think, and this one's just he thinks, they think, I think, he thinks, it's sort of like there's this funny trope in a lot of, like written comedy and film and theater where they say, oh, I know you think that I think that, like, it's us actually trying to articulate that. It always kind of comes off sort of comedic, but I think that's an important part here. And so I think, you and I agreed, we established this third order within the context of our ongoing discussion, so in summary, we've got first order, second order, third order. First order, he thinks. Second order is he thinks, she thinks.
Yeah.
And then third order is he thinks, she thinks,
they think, or
they think, we
something that just imagine it like 3 steps, 3 different.
Yeah, I love that
calculations.
That visual helps me understand this, and ultimately, as you'll see in the experiment, it comes up with and says, look, this is circular logic. This, the logic was flawed and circular. So, that was the fun part of the experiment, to see if GPT-4 could actually determine, or if it was just going to follow it along and just follow the bouncing ball. So I actually was really excited about the output of this experiment, in that it said, this doesn't make any sense. This reasoning, got us into a strange place. Now, there's something else that you and I had talked about before that I wanted to make sure that we touched on here today, and that is this concept of hot versus cold. So one of the things that you had said was, these experiments are great, Cris, is very interesting, but you had pondered whether they were hot versus cold, and maybe there'd be other versions of these. Can you explain what that means in the context of the 3 experiments, at least, that we've talked about here today?
Well, I think we touched on it with that kind of big diagram from the meta-analyses, and it's about whether or not emotion is involved in the decision making. So we've got that ball, which on my screen is on the sort of top left. And I heard what you said about its corpus of data. The data on which it draws is the internet, where presumably, yes, humans have written about and described and articulated emotions, probably ad nauseum.
Sure.
And, there's one thing to know that there are such things as feelings, which is different from feeling feelings and using feelings as part of the decision-making process. So a cold theory of mind is that, logical reasoning based on factual information that ChatGPT-4 can probably do really, really well, because it's got such a wealth of information and it can process things so quickly. It probably can. My hypothesis was it's doing a kind of cold theory of mind really, really fast and quickly.
And by the way, what I can do to embellish that position that you just shared is that what GPT-4 really is a transformer model, and what transformer models are doing, essentially, in plain English, is their completion. Just like when you type into a Google search and it kind of knows what the sentence is going to be, or in your email, it's that, the superpower version of that. So what it's doing is it's actually guessing tokens, the next token, and it's saying, well, this is the most probable next token based on our training set. So when it says something like, if somebody's writing a statement of love or something like that, it's going back into its corpus of data and finding the next most probable thing that someone would say if they were expressing that emotion. So just to kind of give a little bit of tech support to how emotions are expressed within these models and their output.
So for me, there feels like there's a real key delineator there, which is this something that just knows a lot about emotions at a conceptual, kind of more cognitive, conceptual reasoning level versus can it feel? And I suppose my position on that is I come from my philosophical orientation on that is embodied consciousness. So I would say that if you haven't got a body, you can do lots of thinking, but you're probably not doing feeling, which is our core human capacity, in fact, to feel.
A lot of AI philosophers, Tamara, are coming from the same position as you. As a matter of fact, the embodiment part of it is very important to this discussion to a lot of individuals. And I would probably say, when we're asking GPT-4, whether or not it's conscious, I like to kind of think of it this way. Like it has read a ton about, like I mentioned, the feelings and the awareness, and it can think deeply. As a matter of fact, I'll just point to an actual, logic, for example, was discovered, so to speak, by Aristotle. How did Aristotle discover logic? He literally, as a human, used his ears to listen to other speakers and individuals during his time, because there was no recorded, words. And he discovered these patterns, right? Like literally, Aristotle's logic is discovering these patterns within the way people speak. And then that's how he discovered logic. So I'm just here to say, GPT, whatever version, has read a ton. It sees those patterns. It doesn't have to read about somebody talking about logic. It can, in fact, infer logic in the same manner as a human did it originally at some point, right? So that's kind of my position where it's coming. It's maybe a little bit scary, but just because it can talk about it, to your point, doesn't mean it truly feels or understands it. But does it need to? Like, it's a bit like having a smart calculator that can solve any math problem, but it doesn't really know what numbers truly mean. But it gives us the right answer, right? So our own awareness as humans is complex. It's just not about being smart or knowledgeable. But like you said, it's about feeling and understanding and interacting with the world in a unique way. And now my position would be, and I'll let you respond to this because this is sort of my summary of our discussion that we've talked about today. I would say while GPT-4 is very impressive in that regard, I think at this point saying that it is actually conscious as a disembodied entity may currently be a stretch. We would really need to dive into this purposefully. Like what we need is like testable hypotheses to determine whether it can do that, much in the same way that we've used some tests and hypotheses on just can it establish different perspectives. So I'd say we probably would need to start fresh. Maybe language models wouldn't necessarily be the models that would tell us about consciousness. We might get there. That's my perspective from an AI professional standpoint. I'll let you give your summary statement to bring us into our landing of this wonderful discussion about your thoughts from a psychological perspective, because I think that's even more important in the context of this discussion.
Well, I suppose the kind of the phrase, the devil's in the detail, and, does anybody care about the detail in this fast-paced world where everybody's just trying to, compete and get to wherever they're trying to get to. But to me, one possible scenario is we've got something that's sort of got a theory of mind on steroids because of its computing power. It's got masses of experience in terms of the data set on which it draws. It sounds plausible, and it's got excellent sort of face validity in terms of what it's saying and making sense and like, oh yeah, it's really got it. But I think how it's got there is of interest to me, because it may be that it's developing its own unique variant of theory of mind, which may not be the same as what we have in humans. And we also know that even within humans, there's this variability. So one piece of research that was quite interesting was when they gave theory of mind tests using functional magnetic resonance imaging to some high functioning individuals with a diagnosis of Asperger's. What they actually showed was that they were able to solve the tasks, but they were using a different route, and they were using more like a logical reasoning route. And it took longer, which is where ChatGPT-4 would have an advantage, because you won't notice that delay because it's so fast with the processing probably. But when you're maybe meeting somebody, and I think there's probably lots of people in the tech world like this, if I may, you know, actually there's something in the social interaction that just feels like it's just not got the paciness and the dynamics to it. So you can sort of tell. And
yeah, I think that's it. And actually, there's, just to add some value to that, there is some tech out there about assisting people in these social situations, which frankly makes it more socially awkward than less. But yeah, so I think if I were to, I think I found our common ground here. I was stating that the smart calculator idea, like it's giving the right output, but there's lack of context there. You've mentioned, and not only in this conversation, in our previous discussions, the hot versus cold, and maybe it's more of a cold than hot, and certainly the outputs are there. I think we might both agree, as a potential to possibly set up a future conversation and maybe some other experiments, that a interesting testable hypothesis would be to focus on the difference in those areas that are not, how do we make it more hot, or how do we, give it more context, or give it, some emotion to be able to work with, and see if it changes the outcome, or see if that actually has some relevance to it. So, if I may, perhaps you and I can continue our discussions looking at specific experiments along these lines, and hopefully that would be just as interesting and useful as our conversation here today has been. I personally would just like to say, Tamara, thank you so much, not only for reaching out to me, and I'm not going to say you validated my experiments. You just made it really fun for me to have done these experiments and have somebody respond with awe, like, oh my God, these models are amazing. Like, thank you so much for that. And thank you so much for taking time out of your extremely busy and valuable day to be able to have this conversation here. I certainly look forward to future conversations. So thank you, Tamara, very much. I really appreciate your time today, and look forward to digging into theory of mind with you even further in the future.
Thank you, Chris.
Thank you, everybody. We'll see you on the next video. Cheers.